Yeah.
Hello,
Yes.
am I
Good
audible?
evening. Yes, you are.
Hello.
Yes, you are audible. Hello. I guess I'm not audible anymore.
Hello, am I audible now?
Yes, you are audible.
Okay. Good evening, everyone. Good evening, Shubham.
Yes. Good evening. So we
So,
have a number of participants here, which I wasn't expecting. That's very
yeah,
good to see.
right. So it is pretty excited.
Yes. So I've given them an overview on what we are going to discuss in today's meeting. The same thing that we discussed, like what is WebRTC versus the other protocols and how it works.
Right.
Overview, how you used it to build an application and a demo of that. But before that,
Correct.
let's
Correct.
just have small interaction with this with everyone so that we get some idea about their understanding on this technology. Chirag said that he has used WebRTC a little bit. Chirag, you can unmute and please give us some experience.
Okay.
Okay, Chirag doesn't have mic. Okay, that's okay.
Okay.
Has anyone else used WebRTC here? If not so, then we'll proceed with the presentation. Okay, looks like nobody has. Okay, let's start the presentation. Yeah, right.
Okay. So, good evening, everybody. So, my name is Sai Prasad, and I've been associated with Developer Hash for a while now. Um, but yes, I'm recently not so much participating because some of my work. So anyways, so everybody did hear about WebRTC, right?
Yes, I have heard about it.
Correct,
Ajmal.
correct.
Yeah, I actually tried to work with it, but I couldn't find the resource for to learn it.
Okay.
I've gone through the concept actually about DC.
Sorry.
Uh, while eagerly, I'm just how the communication between one user and other user works. Just I have researched it and I found the WebRTC. Just
Okay.
had knowledge on that.
Okay. Okay. So maybe after this session, maybe you'll have some more idea on how it works and the basics of the internal working of this WebRTC stuff, right? So let me share a presentation
Hmm.
so that we'll be able to move on.
Okay.
Right. So Linux does support presenting, right?
Yeah,
Yeah.
it has share screen.
Share screen. Yeah, correct. Yeah. Host disabled participants. Host, please allow me.
Okay. Yeah, now you can.
Thank you. So is the screen visible? Everybody is able to see?
Yes.
Yes, I'm able to see.
Yes, sir.
Yeah. Okay. Please don't call me sir or anybody. Just call by the name. So that would be good. Anyways, so we'll be talking about WebRTC today. So, what is WebRTC? So today's agenda will come to know about what is WebRTC and how it does differ from other frameworks or other protocols that are available, how WebRTC works, and there's an application that we wrote in a company called Teammeet. So how we implemented that, I'll be giving a brief introduction over it and a small demo so that you'll be able to catch up. Right. So basically, WebRTC is a real-time communication, right? So if you divide these two syllables, web and RTC, it's basically real-time communication over the web. So when you talk about web, it could be desktop application, mobile application, or web applications through browsers and all. So recently, the APIs of the browsers are upgraded. So browsers now have a capability to share multimedia data across the web. So it is basically an API that is being implemented in the browsers itself, right? So we'll talk about it in the further slide. Then WebRT is basically a bidirectional real-time communication. So if there are any BTech grads or I hope you understand what is fully duplex and
Yes, sir. I
half
understand, sir.
duplex and sort of basic stuff. So it is basically means both the parties that are involved in the communication will be able to communicate simultaneously at a time, right? So that is what full duplex means. And bidirectional means you can transmit data from let's say one and two are two hosts available, or a one is a host and the other is a participant. So both the way communications can go on. Um, a unidirectional communication example could be a walkie-talkie, where you press a button, push to talk, press a button, you speak something, the other one receives, and the other guy then pushes the button and talks something. So that is basically unidirectional communication. Uh, Sorry, that's a bidirectional communication, but it's not
But it is
full
half
duplex.
duplex.
Yes, correct. So unidirectional means it's a radio or a broadcast where you speak something, other peoples will be able to receive it, but they won't be able to communicate back, right? An example would be a radio. Again, it's not a fully duplex communication as well, because radio only transmits from sender to the receiver, correct? So that's basic stuff. Then we have what are the applications that are available with WebRTC. And we can implement chats, that could be text or video chats, audio communication, the Zoom itself that we're using today. That's based on WebRTC itself. So one very interesting thing that is available in WebRTC is it is peer-to-peer communication. So again, there's some catches. Okay, let's see how it works and all. So primarily, if we compare, the closest protocol to WebRTC would be WebSockets. Correct. So what is a WebSocket? So in a server and a client architecture, if you're using a web application or developing a web application, you might be familiar with a request response cycle, right? And the server and client concept. So I hope everybody knows that.
Yeah.
Great. So so there's a server and there are multiple clients. So if we take a look about WebSockets, how it works, it's basically a bidirectional communication, but it involves server and a client. Correct. So server would be able to send something directly to the client, or a client would be able to send something directly to the server. Yeah, it is through WebSockets. So it is an upgraded version of HTTP, where HTTP is used for request response cycle, where a client will be sending a request, and in response, server process the request and responds with some text, typically an HTML page or other static assets like JavaScript and images, right? But what WebSockets add to the HTTP or the conventional request response cycle is it makes communication duplex and bidirectional, right? So an example would be a chat application where you type something, you directly send a chat message to the other person, and he'll be getting that text message in real time, right? Whenever you type and click on send, he'll be able to see that. So that's where WebSocket comes into play. And if it would have been written in HTTP conventional response cycle, then each message you will be needing to refresh the whole page. Like when you search for a blog or navigate through a blog, for every new article you need to refresh the page to get those articles loaded, right? So that is how HTTP request response cycle works. But if you are implementing a WebSocket or a real-time protocols, whenever a new post is added, you will get a notification, or maybe the page would be, without refreshing the whole stuff, it will be showing the new article that is being uploaded on the current page.
Sir, is it
Right.
like this, sir, Facebook commenting? Because when we comment, only the comment section is refreshed.
Correct, correct. So it is basically using WebSockets, right? If you heard about MQTT, it is based on WebSocket only, where all the other headers and the stuff that makes WebSocket a bit heavy, it strips that out. Okay, so MQTT is basically a lightweight communication where the WebSocket headers are being removed, and only the communication protocol headers that are needed to just establish a communication and transfer the data, that is only there. So if you used MQTT, Facebook uses MQTT to communicate in real time. So
So
yes,
it's only for messaging, right, sir?
sorry.
MQTT is only for messaging, is it?
So it's basically a pub sub architecture. It Yes, it is
Oh,
for messaging, right? But when it comes to real-time communication as well, that could be used. So it is, what I'm trying to say is, it is basically based on WebSockets only, right? So MQTT is a you could see a fork version of WebSockets. Correct.
Also, for WebSocket, the connection never ends unless the client or
Yes,
the
yes.
server chooses to.
Correct, correct. That's a good point, Shubham added. So it is basically, once it's open, the port that is used to communicate through WebSocket is open always. So it is alive, right? So when you disconnect from the server, the channel would be disconnected. Yeah, so that's an important point to add. So that is basically about WebSockets. And if it is a real-time communication, then video and audio could also be shared. That is what we do when we share audio and video through messages, right? Through chats. So that is being done on WebSockets only. But the problem here is you can transfer data and transfer multimedia data as well through WebSockets, but WebSocket is not optimized to stream data, right? So that is where the catch comes in. So the problem here is WebSockets will be able to efficiently deliver text-based data, like if it's a JSON or XML or maybe textual data that you have, that WebSocket would be taking care of, or it can easily deliver those data. But when it comes to multimedia data, so you might have known that every video or audio has a different metadata information, like the encoding, what is the container that is used, what codec it used. So those are all the specifications that are attached with every audio and video file, basically the multimedia file. So it is a bit difficult to transmit over WebSockets, and again, WebSocket, it is not optimized to deliver multimedia data. So that is where WebRTC comes in. So WebRTC is basically for real-time communications, and it supports peer-to-peer communication. So let's go and check out how it works, right? So it uses a framework called ICE, Interactive Connectivity Establishment. So under ICE, we have two types of servers. One is TUN and then this TUN. So you might have known how network works. Let me give you some basics about how network works. So whenever you are connected to an internet through mobile data or through ISP, might be Geo or might be Airtel, Vodafone, whatever it may be. So you always get a, public IP, but it is dynamic. You are not getting a static IP unless you are requesting the ISP for to get a static IP, and that is not at all possible for mobile applications or mobile devices where you won't be getting any static IP, right? So all the devices that are connected through internet through a gateway, so that comes under NAT, right? So what NAT does is it is basically called network address translation. So what it does is it assigns an internal IPs to every devices that are connected to the gateway, right? Why does it do? Because one, IPv4 is you know it has a limitation to how many number of devices it could be assigned an IP address to. So to overcome that implementation or overcome the uh, restriction, NAT is being introduced, right? So whenever you connect to an internet device through a gateway, so first the internet would the device would be connected to a gateway, right? The gateway would be acquiring the public IP that is being provided with by the ISP, right? So again, those that gateway again assigns multiple IPs to multiple different local IPs to the network that is being connected. Like if you have, let's say, computer
To the
A, B,
internally
C.
connected clients or devices.
Correct. Yes. So if you have ABC computers connected to a gateway, then it will have an internal IPs. It will be through subnets like 192.168 or maybe 10.17 based on the subnet implementation or the router that is being used there. Right.
Yeah, it's 0 to 100 range. 0 to 100 range.
Sorry, 0 to 100 range.
0 to 100 range, right? One gateway has 0 to 100 range.
No, it's actually 0 to 255, right?
Okay.
So, depending on the subnet that is being used, let's say you have used 192.168,
Zero dot
then
one or 1.1.
or
The
0.1, maybe 0 dot something. So you will have 0 connected to or assigned to a gateway, right?
Mhm.
So that couldn't be
Yes.
used to connect, used to assign to any other computer, and 255 is for broadcast. So once you publish anything through 192.168.0.255, let's say, so that won't
Mhm.
be able to that IP address that's not allowed to be assigned to any other computer, right? So that's basically for
Yes.
broadcasting.
Okay.
The rest of the IP address that are available in the pool, that is being assigned dynamically through the gateway. So gateway decides, or basically the router decides what device will get what IP address. So it's basically a networking part, right?
Yes.
So
Yes.
so that is the limitation when it comes to peer-to-peer communication, right? So when you're when trying to connect two different computers that are
Mhm.
again connected through different IPs, ISPs,
Mhm.
different carriers. Okay, so
Mhm.
what happens here is you won't be able to directly communicate peer to peer, but WebRTC works on peer to peer basis, right? You basically transmit data from computer A to computer B or device A to device B directly from peer to peer without any intervention of servers. But again, firewalls and
Yes.
NATs,
Yes.
those are
Yes.
present in the
Firewall.
network, so it won't allow
The
certain IP
firewalls handle
addresses.
here. Yeah.
Sorry.
How this firewall handles here? Like if example one IP is A 192.168.40 is one device,
Correct.
another one is 160.
Correct.
Well, if I want to connect 140 to 150 means I have to allow inbound rule in firewall, right?
Yes. So whenever you're talking about WebRTC communications, yes, there are some ports that are
Mhm.
specified by the software that is being implemented in this
Mhm.
network, like let's say an office restricted office network. Then
Mhm.
you'll need to allow some ports using UDP or TCP connections to
Mhm.
be allowed from using the firewall. So if you block the ports in the network, then the communication won't happen. Correct. So
Yes,
that is
yes.
a limitation in WebRTC here. So if you want to communicate peer to peer, so if you want to communicate peer to peer, then you need to have to allow those specific ports to be allowed in the firewall, right?
Okay. In the NAT,
Sorry.
in the NAT we have to configure this ports, allow this port
Correct,
to
correct.
send a
So
message and receive a message.
yes, yes. So in the NAT, and also if you're using a computer that is having an inbuilt firewall in the local network itself or local machine itself, then also
Mhm.
you need to allow those ports, right?
Okay.
So that's a basic thing that you need to do. So the current systems that we use in our home network and personal PCs, those firewalls are need not to be configured because those are already open, right? So but when it comes to a restrictive network, let's say an office network where specific ports are allowed, specific devices are allowed to avoid any data breach and all. The network administration team sets up those network in that way. Then there'll be need to configure a firewall, because whoever is connected to the Zoom meeting now, I don't think anybody configured a firewall for that, right? So it only applies to when there is a restricted network, right? So
It will
back
ask.
to the discussion. Yeah, yeah, you were saying something.
Yeah, it's give a access prompt, so it will allow access from the
Correct,
OS.
correct.
Yes.
So if you're using Windows, then the firewall prompt would be appearing, right? So you
Yes.
will just have to click allow. That's it. So,
Okay.
but you don't have to go to a access point or maybe a router that's lying around, then configure it. So that is not there. So it's basically the inbuilt firewall that is available in the computer that needs to be allowed. So that is what need to be done in the client side.
Okay.
Yeah. So back to the discussion. So it's basically WebRTC is a peer-to-peer communication. So if you're using NAT or firewalls that is configured in different networks, then it is not possible to directly communicate through peer-to-peer. So that is where stun and turn server comes in. So what it does is, let's say I'm a computer and I'm connecting to a stun server that has to be hosted somewhere, right? So I'll connect to the server that has a static IP, right? So that has a global IP that could be directly connected to, let's say, Ubuntu machine.
Public IP.
So first, sorry,
Public IP. Yeah. Public
yes,
IP.
yes, global IP or public IP, whatever you say. Yeah. So let's say a peer A, peer B as shown in the picture. Let's say peer A is trying to connect to peer B and peer B is trying to connect to peer A. So first we need to have a address that should be available to connect from peer A to peer B and peer B to peer A. So how could it be done? So peer A will first communicate to stun server and request or query the address uh, that uh, that it that is needed by other computers to connect it to itself, right? So PRA queries to stun server, ask for it. What is my public IP where others will be able to communicate, right? Then stun servers, as it is a global IP, it will be able to see only the global IP that is uh, that the PRA is trying to connect to, right? Let's say we have a gateway and we have a computer, right? The global IP will be available in the gateway only, but your computer will be having a local IP. So your local IP is of no use to establish a peer-to-peer communication. So when this computer tries to connect to the server, it'll
Mhm.
see the public IP that is being assigned to the gateway. Then
So,
that
mm.
is transmitted to peer A, right? So it is basically
so
querying
you, you
what
mean
is
that
my
the
public IP. Yeah,
you mean that peer A and peer B is connected to that server. Peer A
right.
is
So it
connected to that
queries the
server.
server. It does not connect to the server. It basically queries the server. Like,
Okay, it's
what is my
query.
IP?
So like
Yes.
SMTP works. SMTP like
Uh,
SMTP.
Not SNTP exactly. So it basically that could be thought of a request response cycle itself, but it's in a
Mhm.
different way, right?
It's in a
So
different.
it's like I'm PRA. I'm trying to get my IP address. So I'll go to the server and ask what is my IP. Then it sees that okay, I'm getting this request from this server. So yes, this is your public IP. It responds back to PRA. So the stun server has a PRA address. Again, the same process goes with peer B. Then stun
Mhm.
server has those PRB address as well. So both the global IPs are available. Then the
Mhm.
address is exchanged, right? So the PRB IP address will be exchanged to PRA, then PRA IP will be exchanged to PRB. So once that is done, you'll be able to communicate directly through peer-to-peer communication. So the rest
Oh,
of that we need to do through the server, that is not there. So when there's a one-on-one communication using WebRTC, you're basically not using any server resources. You're directly communicating peer-to-peer. Right? So that's the
oh,
beauty about
okay.
WebRTC, right? So
So
that's about
it will
stun.
connect both the IP address.
Yes, yes. So first, PRA, PRB does not know what IP it is or what global IP they are being assigned. So it will first ask to stun server. Stun
Mhm.
server responds with their public IP. Then those
Mhm.
IPs are exchanged between PRA and PRB. Then PRA and PRB will be directly connected to through
Hello.
I think there is some network issue.
Okay. Okay.
पैसे बन के खुद वो कहाँ पैसा बर्बाद कर दिया उन्होंने सारा सारा पंडित जी का
hello.
Yes, yes.
Hello. Yes.
Sorry, I guess my network is
Yeah, it's okay.
it's facing some problem. So is it visible now?
Yes, yes.
Yeah. Okay. So what was the last sentence that I was talking about?
So you're saying that the peer A and peer B would get the IP address from
Yes,
Stun
directly
server, then they
connected.
would be able to connect to each other. Yes.
Directly, right. Yes, that's peer-to-peer communication. So stun server basically exchanges the IP address, but what about turn server? So stun server will be able to exchange the IP address, but turn server is basically a stun server with some added capabilities. So it will be able to transmit streams as well, right? So let's say if you need some processing to be done on your server end, that's where turn server will come in. So it will basically catch the stream, then transmits to the PRB, right? So turn server is basically a turn server with some added capabilities, right? So this is the overall diagram how it works. So this a peer, this one peer, and this is another peer. We have a firewall here. There's a NAT attached, right? So we have a stun server. So how would you connect the peer one to peer two? And so first, peer one will be accessing the stun server, and it will query the IP address that we have. Then once the IP address is exchanged, then it will go through peer-to-peer communication, and the communication would start, right? So again, once that is done, then we have signaling here. So one part was connecting, establishing a connection between one peer to another peer, right? So once the communication is established, then we need to have some way to uh, basically transmit data from, let's say, peer 1 to peer 2. So data could be text messages, the chats that we basically do while going on with the WebRTC or with the conference. So that's where signaling comes in. So let's say Shubham has joined the meeting. So we are all able to see that there's a notification that Shubham is joining. So those information are being transmitted using the signaling server, right? So stun and turn servers are basically for establishing a communication, and signaling is for transmitting metadata that will help communication to be successful, right? So these are all APIs that are available in JavaScript itself. So the newer browsers that we use, Firefox, then I guess Internet Explorer is already dead, so we'll not be talking about it. We have what is that new Microsoft Edge? Yes,
Edge.
so it's Microsoft Edge. So that's based on Chromium itself, and so Chrome, Edge, Firefox, and Safari has some issues with WebRTC, so that's not yet matured in that front there. But yes, these three major browsers do support WebRTC well, right?
Is
So
it
the
standardized?
basically, yes, it is standardized now. Yeah, these APIs will be available across the platform, or across the browser
Okay.
platform, whatever it may be. It is being developed by Google itself, so Edge and Chrome will always be updated, but eventually, whatever new updates are rolled out in Chrome and Microsoft Edge, Mozilla is trying to pick up. Right? So there's a bit lag between those two browsers, major browsers, so to say. So the WebRTC APIs include Navigator object, where you will be able to query all the audio and video devices that are available in your system using plain JavaScript. So if you fire up the console and your browser, you'll be able to see what are the devices, like a microphone, or maybe the screen. If you have two displays, then displays what is it address. Those information are available in JavaScript console. So just imagine what could be done using those APIs. Then we have RTC peer connection object that is there this class will be helping to create and negotiate peer-to-peer communications. And for RTC data channel, it it is basically transmitting data from one peer to another peer, or exchanging data. So the real communication happens with RTC data channel. So that's basically how our WebRTC works. I guess I'm clear here, or maybe you will have a fuzzy idea now. So if you have any questions, then you can ask now on how WebRTC works, or else we'll move forward.
Yes, so
Anybody?
I have one question.
Yeah,
So it works peer to peer,
correct,
and for streaming, we have to introduce a turn server for processing, right?
correct. So it's for connecting. It is basically for establishing a connection. You need a stun and a turn server.
Okay. But the stream that will be generated from one device or from one client will directly be sent to the another peer
Correct,
without any processing in between.
correct. So that is why
Okay. So now, yes, yes, please.
so that is why there is a data consumption, more data consumption when it comes to peer-to-peer communication, right? So it is basically
Hmm,
transmitting your
hmm.
data from one to other computer directly. So there is no video processing or maybe compression involved, because you don't have a server.
Correct.
So that's why there would be a slight
Yes.
extra data that is being consumed. Yeah, you were saying something.
Yes. So, so in one way, it will be fast because the latency will be less
Correct.
because we are directly connected from peer to peer.
Yes.
But in another way, when we think about it, let's say if there are 10 members or more than 10 members joined in one call where
Yeah.
everyone is connected peer to peer to fetch the
Correct.
data.
Correct.
So in that case, uh, will it not affect the amount of data that my client will be processing? Because I'll be taking feed from all the peers that is connected for this particular meeting, let's say.
So when you talk about multi participant communication here, so it is not the peer-to-peer communication that's happening, right? So we have multiple topologies that are available in WebRTC, like um, so one is peer-to-peer, where you will be communicating through other peers directly. So all the streams will be interchangeably connected, right? So
Mhm.
for other parts, just a moment, I forgot the names actually. Yes, one is mesh topology, right? Mesh topology is basically connecting all the other peers to all the other peers, right?
Okay.
Then we have MCU, right? So it's a mixing topology where all the streams are mixed somewhere in the server, and a single stream mm, is relayed, right? So and other we have SFU, single forwarding unit. It exactly is
Okay. So in general, let's say
right.
if there is a multi-participant use case and
Correct.
we have to use WebRTC, how would WebRTC
Mhm.
handle in that case?
See, when you talk about multi participant communication, so there is no peer to peer. That's a bad way of implementing WebRTC, right? So you should not
Okay.
implement a peer to peer communication directly here. So you need to have a server where the server would be relaying all the streams. Let's say we have 10 participants, the server will be receiving all the 10 participants streams, right?
Hmm.
So, but when transmitting those streams from the server to the clients, then all the streams that are available on the server, whatever that is being received, that will
Mhm.
be transmitted to all other participants that are connected to the server, right? So it
Kind
is
of
not
like broadcasting.
actually yes. So it is not basically peer to peer happening here when it comes to multi-party conference. So
Correct.
it is a central server that will be relaying those streams, right?
Okay.
So
Okay.
it will not be processing anything. If you're processing, then you're talking about MCU, right? It is mixing and other encoding and compression stuff going on, right?
Hmm.
So there is a SFU topology where you basically relay those streams, right? So let's say
Hmm.
if I'm streaming my data, maybe 720 pixel or 480 pixel, so those quality or that quality will be remaining when streaming back to other clients, right?
Okay.
So so that is the way that is implemented for the multi-party conference.
Okay. Yeah. Please.
Any other questions? Any other questions, or shall we move on?
I think we can
What
move on.
is
Oh, sorry.
Sun?
Yeah, you were saying something. I guess the username
Sun?
is Doodly.
Can you explain about Sun server?
Sorry.
Sun server. Sun server.
So you need what information exactly you need about Stun server?
Yeah, the Sun server. It's like if
So
example
it's
if
a
you're
basically
hosting.
a program. It's a program itself. You when you type about Stun server directly, you will be able to see a lot of servers. One happens to be iced.
It's like a web server, like application server, like that. It's Sun server.
Yes, yes.
Just
You can directly search it on over Google. Let me check if I can uh, give a good software example exactly.
okay.
Coturn happens to be one of the stun server that's open source and available on GitHub. Right. And Red 5 Pro is also a stun server, and but it's paid. Again, we have Trickle, and there are a lot many other servers that are available. Right. So there's a huge collection of servers, ton servers, and ton servers that you can use for exchanging the IP addresses. Right. So you can start with Coturn, Coturn. So that's the server that I'm talking about. Sorry. So yeah, I guess you understand how turns and stun server works, right? So you were asking about what software or program that is available to implement that, correct? Or did I
Yes.
misunderstood? Okay. So any other questions?
It's a service, right? It's also a service.
Yes, yes, it's a service. Yes, it is a program that is running in a Linux operating system in the background. So you don't have any commands to be
So
run
we
all the
can
time
also,
to start it.
like example, the Twilio.
Sorry,
Twilio. Twilio uses
Twilio.
like yeah, specifically.
I don't know what exactly Twilio uses for its web-based communication. I never checked out its use case. But Jitsi happens to be one of open source server, right? So I guess it implements its own term server.
It's like a stun form ice type of services. Therefore, so it's also it's for different
Sorry,
purposes.
couldn't get you. Can you please repeat that
Stun,
again?
stun, zone, and ice. These are three different types of servers, right?
Yes, ICE is basically a framework.
Okay.
Sorry. So under ICE framework, we have stun and turn servers.
Okay.
So it's basically like Node.js. That's a engine, right?
Yes.
But you have uh, what are the frameworks that are available in Node.js?
Express.
Socket.io Express. So you
It's
can think of that like that.
node model.
Yeah.
So did you got the point?
Yes. Yes.
Okay.
Yes. Thanks.
So shall we move on, or any other doubts you have in your mind?
Yes, we can.
Yeah. Okay. So that is basically how WebRTC works. One of the example use case that we built is Teammeet.
Lost the screen.
Okay, I'll just share the screen. Just a moment. I'll share the entire screen. So is it visible?
Yes. Thank you.
So teammeet.in is one of implementation of the WebRTC protocols that we're talking about. So that was implemented by our organization. Right. So it is based on Jitsi that I was previously talking about. So you can basically start a meeting just by entering an ID, right? So those APIs, the navigator APIs that I was talking about, those are implemented here. So you need to allow it, and that's the meeting ID, teammate.in slash what is the ID that you are able to see. Then you can enter your name. Let's say join the meeting. Then for security, we have implemented uh, an authentication kind of protocol here. And then you need to type in the password. Yeah, so So the meeting is started. So whoever wants to join the meeting, you basically have to copy this link and share it with the other person, and then they'll be able to join. Let's say I drop it down into our conference currently. Where is it?
Should be in Zoom software. Yeah.
Yeah, yeah. So you can click on it and directly join. So you will not require any password to be entered. And so it's basically the user interface that you will see here. Like we have other controls also, like you can chat with other participants, then you can share your screen that we are able to do in Zoom. Then we have raise hands. When you raise a hand, there's an audio feedback that you will be able to hear, right? Then there's a recording facility here where you can record the whole conference and store it in the local system itself. So all those features that are shown here are basically using those APIs, those basic APIs that I was talking about. That's a navigation API, right? Navigation and a media recorder, media streams, that are all available in JavaScript, and those are standardized also, right? So those APIs could be used to yeah, implement all this stuff. And then we have a gallery view to see who are all are connected. Then uh, you can, if you are a moderator, like if you are logged in or authenticated yourself, then you'll be able to see a list of moderator actions that could be done. So one happens to be unhide, so I guess that's a privacy breaching thing. But our use case was something else, so we implemented that. So if you're clicking on unhide video, then I guess Rahat will be unhiding his video directly, right? So that's a bit.
I don't think you will be
So
very pleased.
yes, so I'll not be doing that. Okay, he disconnected already. So I'll not be doing that. So that happens to be one of our use case. So we implemented those that feature. Then we have unmute also. So we thought of implementing this in a school like environment, or basically a school environment where children are not very much accustomed to whatever the features that are shown in their desktop, or maybe on the phone. So maybe when you're telling a student to unmute yourself, you're wasting a bit of time there. He'll not be able to understand where to click or where to not. So that is where moderator control for teachers will be very helpful here, right?
Correct.
Then we have invitations. So invitations could be through copy link. Then we have default email. So it's basically asking your system to open the client that is configured locally, or you can click on email and it will take you to the uh, Gmail page where the logged in mail will be shown, and you can start typing the mail there. Then you have same thing implemented for Outlook and Yahoo Mail. So you're basically covering uh, popular mail clients or mail servers that's available. Then you have security options where you can enable lobby. Enable lobby is basically, so Shubham got in directly, right? So if I want a moderator control to be able to restrict whom to allow users to join or whom to restrict, so that's where lobby will come in, where the moderator will be able to allow and decline requests that are shown in, right? So again, we have a password. Let's say there's a lot of people that are connecting to the system. Then it is not wise to enable lobby and accept decline every other participants. If you have, let's say, 100 or 200 members, then that's where password will be very helpful, where you'll just share the password prior to, let's say, 15 or 10 minutes. Then when they're getting in, they'll be asked a password to type in. Then mm, you type in the password and you can get into the meeting. So that's what Zoom does actually, right? Then we have other moderator features.
That's really impressive.
Yeah. So other we have whiteboard. Let's say you click on the whiteboard, right? And yeah, you have the whiteboard. Whatever you write here, let's say I'll share a link. It is basically using an open source software that's available, but still, let's say I want to share this whiteboard to with one of our teammates. Let's say I'll share this link and put it on chat. Right. So, Shubham, can you please click on this link and draw anything you
Yes,
want?
yes, sure.
Yeah.
Yes, yes.
So you will be able to see whatever Shubham draws from his end. We'll be able to see here, right? So that's basically how real-time communication works here, right? So it is based on
So
WebRTC only. It's not actually WebRTC; it's WebSocket, right? So we have implemented both WebRTC and WebSocket here. So WebSocket is for transmitting textual data or other data that will be that is very helpful when you're drawing on screen or maybe sharing a file or something like that. But when it
so
comes
it's
to
a mix of
transmitting,
both. I mean, this application
yes, yes,
implements the mix of both. Okay.
correct, correct. It is a mix of both WebRTC and WebSocket as well, right? So there's another signaling server that I would like to talk about. If you're not sleepy, so
Yes, yes, please. And please don't draw anything vulgar, whoever is trying that. I mean, this will be uploaded to YouTube.
so yes, so I was talking about yeah, signaling server. So we have used Prosody here. So that's a Lua based program where you will be able to send messages from client to servers and server to clients. So it is based on something called what does WhatsApp use it? WhatsApp is based on, Shubham, can you help me here? What does WhatsApp use for communication?
Hey, my
It's
knowledge
not
is a little weak
written.
there. I'm not really
Uh,
sure.
WhatsApp protocol. I always confuse with yes, XMPP. Correct. Yeah.
What is that?
So that's an alternate XMPP, Extensible Messaging Presence Protocol. Right.
Okay.
So that's the same protocol that we're using in communicating to the server. Right. So one of the server happens to be, if you ever heard of Jabber, let me just open. Right. So this is an XMPP protocol, and Jabber happens to be one of our software that implements XMPP protocol well. And WhatsApp is a good example of XMPP on scale, right? So whenever you are trying to message other participants in a group or maybe peer to peer, then you're basically using XMPP. It's a stripped down version of the request response cycle. So you have an heartbeat here. Let me show you the console. I guess. So yeah. So you will be able to see there is an XHR request that every 10 seconds the server is configured to transmit an XHR request for every 10 seconds, right?
Mhm.
So
Isn't that short
this
polling?
happens to be one. It's basically short polling, yes. So XMPP basically works on polling only. So it is like heartbeat signal that it lets server knows that yes, I am still alive, right? So that's not happen. That does not happen with WebSockets here. WebSocket is basically using a socket or a pipe using a
Correct.
port to connect both server and the client. But when it comes to XMPP, it is basically polling. Like yes, I'm every 10 seconds I'm sending to the server. Yes, I'm alive. I'm alive. I'm alive. So that's going on here that you can see uh, in this request
Okay.
console, right? Yeah.
That's what WhatsApp do.
And another cool thing, yes, that's what WhatsApp do. If you have delayed internet connection or maybe what would be said, a slow internet connection, then you might have seen a notification where WhatsApp uh, is checking for new messages that pops up.
Correct.
If you ever
Okay.
seen that, so it's basically the polling that is happening here. So it is checking with the server that are there any new messages that are available on the server. If yes, then put me in, right? So that's what our WhatsApp does. And another cool thing that we have in our Chrome browser, but I don't know how many people know that. So it's the Gmail that I was talking about. It is the message body that you can type and send it directly to the other participant. So Chrome has a WebRTC internals, right? So when you're using WebRTC over Chrome, so this is the address or URI that you will be able to type in and check out all the information that are processing in the background, right? So it's a signaling state. So how did it get connected? What all things that are being used, right?
That's a detailed debugging kind of thing, huh?
Yes, yes. So it will be very helpful when you're developing WebRTC based stuff, right? So Chromium and Chromium both provide a lot of details here. So it provides graphs as well. What is the audio level that is being transferred? Let's say I'm muted here. Let's say I'm unmuting it. Hello. You
Yes.
can see the audio stats here, right? The
Correct.
samples and audio level, RMS value, what the energy that audio is shared. So those information you will be able to see in real time, right? So there are a lot of other information. What let's say multiple people are connected, so you can see all the stream information here in WebRTC internals that is available in every Chrome browser and in every Chromium browser. You can even see it in on, I guess, Microsoft Edge. I don't know if they stripped that out, but I think they have it. Right. So yeah, so it is basically how Teammeet works. So I was talking about XMPP, right? So the chat implementation is through XMPP only. When you message something, let's say hi, you're typing something, and the chat is transmitted. So it is basically XMPP that's working in the background. And for XMPP implementation, we have used something called Prosody. Prosody XMPP. So this is basically a server that clearly implements XMPP, right? The protocol. And if you talk about multiple XMPP clients or server that are available or any other alternative softwares, then we have Edge Upgrade and OpenFire, and we have Mongoose. XMPP
Is
Jitsi
it open
also
source,
have a,
Prosody?
yes, Prosody is open source. You can get in and get all the source code there, but it is written in Lua. I think
Okay.
you have heard of Lua. It is basically used for developing games there. But yes, they
Yes,
have
yes.
chosen
In
Lua to
GTFI, it's
implement
used
this.
Lua.
Sorry.
Yeah, in game like GTFI, it's used Lua plugin. Lua
Yes, exactly. So it's very helpful in building games, right?
building games. Yes.
So Lua Rocks is basically the I would say library which is used in Prosody, right?
It's a
So
script. Lua scripts.
yeah. So I guess that's all about today's WebRTC conference. If you have any questions that you want to clarify or any other points to make, please go ahead.
Yes, Chirag has one question. And it's pretty simple. It's, will you going to create simple sample project of WebRTC?
Um, uh, if you're talking about sample projects,
Or maybe
there
just
are
you
already
can just
available.
give us some reference to follow.
Correct, correct. I'll just Webrtc sample projects, and that there are a lot many projects that are available here. So starting from how to capture audio, how to capture video, how to transmit audio. So you have all the other open source projects that you have. Yeah. So these are the samples.
Amazing.
Webrtc Git repository. Yeah. I'll just share the link
Yes,
in
yes.
this chat. I guess that will be helpful. Where is it? Yeah. So it will explain all the APIs that are available in Webrtc and browsers that you will be able to use. And okay, we create one-way broadcasting using Webrtc. Yet, yes, it is possible, um, but you don't really need a turn or stun server. No, you'll need that because when it comes to Mac, then you'll need a turn and stun server. So yes, that is possible. Webrtc does support broadcasting. So, but you need to do some tweaking in the server side. So your server should be able to capture all the information or the video streams that are published from the client end. Then it will internally share it with a broadcasting system. Let's say if you have an Nginx server setup, or if you have a Red 5 server setup, then the stream would be redirected there, and you can use that IP or the address that is generated from the broadcasting system. And then you can broadcast all the streams to the other clients. Right?
So one more doubt though. If a
Yeah.
peer gets disconnected, does it reconnect itself?
Yes, it does. We have implemented it in Teammeet itself. So
Is it
it
is
is
it a manual
basically the
process?
yes, it is a manual process. You need to create a loop there. Then you need to try to connect using that. So you're basically using the signaling server here. So the thing that I have shown in the network
Correct.
tab, right, in the
Correct.
console. So it will try to connect to the server, then it will fail. Eventually, it will try to reconnect again. So that is why short polling happens here.
Oh,
Did you
okay.
suggest any package related to WebRTC? There is no packages as such. The APIs that are available on Chrome or Firefox or whatever major browsers are, those are pretty much straightforward, right? So that's the implementation that depends. If you want to exactly directly implement a framework, then you can check out libjitc. I'll just share you the link. But they have implemented to support their server. I guess you need to implement it yourself if you want to make changes, or if there are any custom requirements. uh, yes, it's the libjitc, and that is used. I'll share you the link, you can go through. Yes, ph.js, but I never used it, so I don't know. Any other questions? Thanks, Chirag, for active participation. Any other questions? Shubham, if you have any.
Yeah. Hello.
Yeah, you were saying something. Yeah.
Yeah.
Please go on.
Yeah.
Yeah.
It's yeah. The session is really useful. Actually, I don't have any query.
Okay. Thank you. Sure,
I have
Chirag.
shared.
We'll plan it. Yeah.
Okay.
What's your name? Actually, Dudley, Dudley Bhai.
Yeah, my
So,
name
what's your
is
name
Shafi.
exactly?
My name is Shafi.
Safiq.
Yeah,
Shafi. Okay. Okay, Shafi.
Yes, Shafiq, thank you for the questions.
Yeah.
yeah. Thank you, thank you, thank you.
And
So
expect more session on WebRTC practical if possible. So I think you have shared a link, a resource on how to get started with WebRTC. What I'll do personally is I'll try to write a very simple code for one-to-one interaction, let's say, with WebRTC,
Yeah.
and
Correct.
then probably likewise if someone else can also write some other code using those samples, and maybe we can have more discussion on that, like bringing up more doubts and all.
Yeah. Yeah. Sure. Let me share one other link. I guess that will be really helpful. It's legit It is the low level API JavaScript API, and they include a great example here. I don't know where is it. Doc. Yeah, in the example part. So they're implementing those libgitsime that they have implemented and created a simple example. It is in the plain JavaScript only, but they are
Okay.
using their server. But I guess it will be a good start. Like if you want to know about internal structure and all, I'll
Okay,
share
that's
this
amazing.
link as well. Yeah.
I think it will help us to introduce this multi-user chat or multi-user video chat, audio chat in our in our
Correct.
application later on, like this studies.
Yes. Yes. Correct. So I guess I have suggested that maybe we'll think about in the future. I guess I'm already lagging behind with the front end itself.
No, no, it's okay. Okay, I'm not sure if this links will stay, so I'll just copy paste it real quick. And
Yes. Yes.
thank you for this
Sure.
amazing session. Really, I mean, in
And
just an hour, I learned more than I could have if I myself went there and searched for WebRTC.
no, just I'm
actually,
really
you have
glad that
simplified, given the definition. You have given very simplified
Correct, correct.
definition to understand.
Also, a practical approach he showed us, like how, where to use, how to use, where not to use, and all that.
Yes,
I'm
now I
glad that
have like
that helped
overview of
everybody.
stun, turn, and the ICE framework.
But let me say, tell that's a bit oversimplified explanation, but it gives you the foundation to work more on
Work
that,
on.
right?
Yes, yes.
Yeah.
So basically, I have to like the ice gathering state change. Like ice is the framework, right? It stables
Yes.
the
Yes.
connection. That stables the IP, right?
Yes. Yes.
Okay.
So it's like a function to call on different like whatever we want, we have to do work on the function and implement in the
Yes.
WebRTC.
So you basically will have a lot of other frameworks that are available readily to be implemented. But the functionality, the core functionality or the business logic that you want to implement, that's basically upon you. How would you implement that? Like you have turn server. Let's say you don't want to use it as a turn server. You just want to able to create an application where peer-to-peer communication happens and maybe chatting is what is primarily needed. Let's say that's your use case, then that could be done. So it's basically the use case that you're trying to implement here, right? So technologies are available, those are open
I have
source.
seen your product on yeah, I have seen your product on Code Canyon. Code Canyon. I've seen your product. That your product, right?
I
Teammeet.
don't know. No, no, Teammeet is not on Code Canyon.
Okay. It's on Google Play. It's not. It's also not in Google Play.
Yes, it's on Google Play and it's on iOS App Store as well.
Benchfab. Benchfab.
Yes, yes, yes. That happens to our be our partner company. So we are basically collaborating on this project. Yeah.
Okay. Okay. So which technology you have used?
So we have multiple technologies here. Whenever you talk about video conferencing solution or as a product, so it's not the Webrtc that has to be taken care of, but there are management panels and management stuff that has to be taken care of as well, right? So for that we have used Python. Then for the internal communication and signaling, we have used Prosody that I've already told. Then for communicating or signaling about the participants, there's a package called GCOFO that we have used there. Then we have JVB, Video Bridge, where all the streams are collected and transmitted to other participants. So that's basically written in Java. Then Prosody is written in Lua. Okay, and then backend panels and all are written in Python Django. So there are multiple programming available here,
For
right?
UI, for UI,
And again, the front end, that's React.js.
React.
It's React.js and TypeScript. So that we have used here.
So
And for mobile
it's a web
application, then
web app. It's a web.
yes,
It's a
web
web.
app.
Not a native.
No, it's not a server and application. It's a basic front end
Web.
application. It's written in React.js itself. Then for the mobile application part, it's written in React Native. So those are the
So
technologies
it's a
that
web.
are.
Okay.
Yeah,
Thanks for sharing this. Thanks.
sure, sure.
Yes, thank you, Sai.
Yeah, thank you, Shubham, for the opportunity.
Thank you so much for teaching us this amazing technology and especially sharing your knowledge with it. And the application, it's really amazing. Like I can only imagine myself building this alone. Okay, and also like I think it's much better than Meet, Google Meet, because it has more functionalities like you see recordings, and then plus the interface is more like Zoom, which I like. But unfortunately Zoom has 40 minutes of limit and all that. So yeah, maybe we can discuss on that, like is there a possibility of us shifting there or something, or doing some sessions over there? What would
So I'll
be
be
like the
really happy
limitation
to.
and all?
Yeah, it's
That
a
I'll be
developer
really
based
happy to.
application. Developer functions, all the functionalities is covered here in this application.
So I'll be really happy to introduce it to our community, and if that is possible, then uh, we'll be able to get a beta testing results here, right? So let's say
Yeah,
there
that
are
would be
10 or
amazing.
20 people.
Sure.
Yeah.
So there is no limitation, right? Like 40-minute limit is there
No,
on
no,
free.
no. There's no limitation as such. No. Yeah.
Okay. So what we'll do is we'll do the next Sunday or Saturday meeting. Let's do it on Teammeet.
Yeah, sure, sure. I'll be really happy to. Yeah.
Awesome.
So, sorry, one more question. So you use AWS for this
Yes, yes.
or Google?
It's the backend
AWS?
is for AWS. Yes.
Yeah, the stream service, right? We have to use it for that, right?
No,
AWS
no, no,
stream.
no. No, no. We are not using any stream service. Stream service is actually written by us only. So
Yes,
it is
it's
basically the container EC2 service.
EC2. Okay.
EC2,
Okay.
yes. It's the container service that is AWS offers. But when you're talking about WebRTC or real-time communications
Mm-hmm.
or audio video processing here, then you need to take care of the bandwidth, right? So
Yes, it will
everything is
it will charge you
on
higher and
bandwidth. Yes, yes. So it's really costly if you see it
yes.
that way, um, because you need at least
The
a 1
cloud,
GB or
the
2
cloud
Gbps.
server, yeah, its handling part is really important in this type of application, right? Otherwise,
Correct, correct.
it'll be a nightmare.
It will collapse. Yes, yes. Whoever works on server administration, he'll not be able to sleep.
Understand that AWS is so costly.
Correct.
Okay then.
Yeah.
Yeah.
I think we can wrap up, right?
Yes.
Yeah.
Thank you all for
Thanks.
joining. And a lot of people left, but they have joined. Thanks for that. Thanks for Chirag for introducing more people to this meeting. And thank you, Sai. That was amazing.
Thank you,
Thank
Sai.
you.
Thank
Thank
you,
you.
Shivam.
Thank you.
Yes,
Thank
thank
you.
you.
Thank you for joining. Yeah.
Thank you.
Bye. Good night.
Good night.